degrees. All right, it
Right.
looks like 8.
Are you ready to rock?
Absolutely.
All right. Good morning. Welcome to what might just be the most underground talk you'll hear all year. Our speaker today started out terrified of bugs and somehow ended up spending her days at Rentokil-Terminix's North American Innovation Center in Dallas doing termite research. She earned her master's in entomology from the University of Florida, where she trained under one of my heroes, Dr. Nan Yao Su, the legend who invented Centricon. If termites have a nemesis, she's it. Today, she's going to pull back the curtain on how these silent destroyers actually live and why understanding their biology makes you a better defender of Texas homes and businesses. Please welcome senior entomologist, termite whisperer, and recovering bug phobe, Hunter Bergbower.
Thank you so much. That's such a fun intro. I love it. Um, I'm going to apologize in advance to everybody watching. While I would love to have my camera on and also sound a little better, I'm currently under the weather. So hopefully I can still get my energy to communicate through this, but just a fair warning in advance. I'll try not to cough directly into the mic, but I can make no promises. Um, So, as Jason said, uh, I trained under Dr. Sue, and currently am employed at Rentokil-Terminix at their innovation center here in North America in Dallas, and I genuinely really enjoy doing these kind of speaking engagements. I've spoken at Kansas Pest Control Association, ESA, and love giving tours and stuff at our location. But I'm also down in the dirt doing field work on the reg once we stop having weird random freezes. So, interestingly enough, my fieldwork has transitioned a little bit from fieldwork out in the middle of the forests and the swampy areas of Florida to working a lot with our commercial customers because they end up having once we get them under contract, they are some of the best places for us to source termites for the experiments that we do at the North American Innovation Center. So, while that's a lot of what's going on with me on the day to day, my goal today is to really talk to you guys about termite biology and also what I call the how and the why of termite control. Because one of the things I've tried to do is empower PCOs kind of across all the different groups that I think a lot of training is really good at saying, here's how we do pest control, but how does it work? It's one thing to say this is the steps you take to do it. It's entirely another to understand how it works. So hopefully that'll give you guys some good insight as well as some fun, credibility building information about termites to empower you guys. So the beautiful basic basics. There are about 3,100 living and fossil species of termite, with, depending on who you ask, about 363 significant pest species. And I'm sure you guys are familiar with these. The Formosan subs, Eastern subs, drywood termites, and then the occasional dampwood termite will come up as a pest, but fairly rarely. There's also Coppertermes gestroy, that's a pest specifically in South Florida, which I'll touch on them a little bit later. They're my personal favorite kind of termite, if only because that's what I worked with during my degree. Again, I always re-say this, and I'll hammer this home till the day I die. Termites are roaches. They are roaches. They might not look like roaches in their worker or soldier forms, but I specifically put pictures on here showing how, yeah, if you look at a king or queen or those alates and reproductives, you can kind of see how they do look a bit like their other family, their family members from way back when. An important thing to know about termites that is very significant for our later conversations is they are what is called hemimetabolists. So, what that essentially means is that they molt repeatedly over their lifetime. And if you look at these pictures here, on the left column, you'll see a really, really kind of clear, translucent looking bug. That is a soldier that is just molted, and you can just barely see its mouth parts. They look almost like a balloon animal. And then, of course, what it looks like once it is sclerotized and melanized. It's actually really fun to say that the top two photos here are ones that I actually took on a really, really cool microscope. And that bottom right one is one of mine as well. It just gives you some context as to when they've molted, they are really, really squishy and really, really clear. And they do that, depending on the species, about every 45 to 90 days, depending on the species and the life stage. Termites are eusocial. Of course, that means that they have cooperative brood care, overlapping generations, and reproductive division of labor. Essentially, what that's saying is that the siblings take care of the other siblings and the parents, and it's just one big, happy, cohesive family unit. But also that there are only specific individuals that are able to reproduce completely. So in the case of termites, what I often say is termites don't really have genders or sexes in the traditional sense because the workers and soldiers are perma kids, they're perma children. So if you talk to people about bees or wasps, which is the really common discussion for eusocial insects, most of you will probably know that they are predominantly female. The males are drones, not super useful to the colony, kind of a burden. That is not the case with termites. The workers and soldiers are all of indeterminate sex or gender because they never reach sexual maturity. Obviously, ants, some sort of gall wasps and aphids, some beetles are eusocial as well. But there are also some other fun eusocial critters out in the world. Snapping shrimp are completely eusocial, and so are naked mole rats. Naked mole rats are the only eusocial mammals, at least that we know of, that meet those formal, very specific traits of eusociality. So very, very cool. Termite gas. Obviously, you guys have heard of this. I've kind of touched on this already, but what are the 3 casts? If you want to drop that in the chat. Again, like I said, this is probably not new news to you guys. Excuse me. So, workers, soldiers, reproductives. It's almost like I said it a minute ago. So, this is true across all the different species you're going to see: workers, soldiers, reproductives. Occasionally, you will see secondary or tertiary reproductives, depending on the species. That is very common to see in eastern subs. I have yet to personally witness a secondary reproductive in Formosans. Lord knows that they're stubborn enough that I wouldn't be surprised, but I've never personally seen it. And I'm sure you all know this, but I'll just rehash it again. Workers do the work. They are the ones that are feeding on the wood. They're the ones that are building that carton nest material or mud tubes. Soldiers can't feed themselves. Those mouth parts are purely for fighting and decoration. So they're not actually able to feed themselves without the help of those workers. And once reproductives have reached a certain level, they're pretty much useless for anything other than making more of themselves. So this is a fun one. How long can termite reproductives live? I want to see. I'm actually going to hop over to the chat because I want to see what people have to say about that one, because this is one of my favorite questions. I want to see if anybody has anything to guess on this one. Let's see here. Any guesses for length of time? 20 years. Okay, I like that. Thank you, Travis. 20 years is a good guess. Anybody want to throw anything else? I appreciate you for your group participation, Travis. That's a good call out. Anybody else? I'm gonna give another couple seconds. 25 to 40. 10. Okay, these are good guesses. So 25 to 40 is a good call out because we're looking about 15 to 30. So a lot of those guesses are spot on. 20 is great. And a lot of these are really good guesses, but there are some species where reproductives can live as long as 50 years, which is, I don't know about you, but that's kind of crazy, because a lot of times when we think about insects, we're thinking about lifespans in the weeks. And when you think about termites, that means we're thinking in generations of humans almost. And one of the things I'll point out here is I have actually been lucky enough to see personally a 13-year-old colony that was at the Sioux lab, the Sioux Chevank lab, and it's gigantic. That thing goes through wood like a paper shredder, which is absolutely insane. And it's also worth noting, when I made that comment about we're talking the scale of human generations, one of the things that makes termites extremely hard to study is this time frame. And as I move forward, I'm going to touch on it a little bit more. But colonies take a very long time to even reach maturity. So if we're talking about doing studies that require full colonies with reproductives and their offspring, that means that it's going to take several years of raising them for the colony to reach maturity enough to be useful. And that's actually something that I've been working on at my new job here at Rentokil-Terminix, is making sure that I have been raising these termites. Now, I joke, I've got toddlers. I do not personally have kids, but I have toddlers at work because my colonies are just about ready to reach about a year and change. And I'll be hopefully collecting some more this coming year. So, how do colonies actually begin? What does colony foundation look like? Because this is something I've had to do and help facilitate in order to get colonies going. So, first and foremost, these alates, these beautiful, I've heard them called swarmers. The formal term is alates, but swarmers, reproductives, kings and queens, take your pick, all of those words are appropriate. They are winged, and once temperatures reach a certain threshold for long enough and humidity reaches a threshold for long enough, they will exit their colony in these big old swarms, which I'm sure, as most of you termite control experts will know, those wings are kind of our key pieces of information that there's probably an infestation somewhere. Because as soon as they've had that, they call nuptial flight, so that marriage flight, those wings will either bite them off or they will break off. And then they will do what's called tandem running, where they will essentially just kind of run behind each other to try and find an appropriate place to establish. Now, this is kind of a choke point. It's why when you go to a home where there's been an infestation, you see not just a couple of wings, but a ton of wings, because they really have to output a ton of alates, because there is a significant chance that they're going to fail to establish. And that failure to establish can either be same-sex pairs that are not compatible to reproduce. That can be not finding a sufficient place to start a colony. So if they end up in a really rocky area with no access to moisture for subterraneans, or no access to wood, they're kind of in trouble, and that's the end of the game for them. I also have a note on here about symbionts. So their gut microbes, the symbionts that live inside their gut that help them actually digest wood, there is a specific amount of them that exist. I want to say that there's about 6 in Formosans, 6 to 8, I believe, specific species, right? And one of the things that's really crucial is, in order for their offspring, for the king and queen's offspring to survive, they have to have a certain, Venn diagram of overlap and different types of gut symbionts in order to survive. This may be because they're trying to prevent inbreeding, because obviously if your colony mate, if in this case their sibling ends up being who they end up dispersing with, that's not good for genetics per se. So their lack of compatible symbionts may be what's preventing them from reproducing correctly. So assuming everything goes well, assuming that they find a good place, assuming that they are compatible in all those ways, they start doing biparental care. And I love these photos because oftentimes when we do termite control or when we're out in the field, this is magic. This is the secret behind the scenes stuff that in theory is happening, but you don't really ever get to see. It's one of the parts that I get to see that I always am super enthusiastic to share. Yes, those little air quote larvae are the little baby termites, and those eggs. I have had to. This is one of the things that I've had to do here for my job when I was getting my degree, is count termite eggs by hand. And I will tell you, there is nothing more humbling than having to sort termite eggs and actually count them, because as you can see here, we're not talking grain of rice size. We're talking grain of sand size. So as you can imagine, that is a very annoying process, but super useful. And it also tells you how durable they are. So when I say biparental care, for a long time, we thought that the king and queen both contributed. And a very good friend and colleague of mine actually was able to genetically prove, using those symbionts, that both the king and queen are feeding their offspring, are providing trophallaxis to those offspring, because both of their groups of symbionts show up in their babies. So we do know that the king and queen both do equal work for this early start. And of course, once those babies reach a certain age and there's enough of them, they switch to alloparental care. This essentially just means everybody chips in and the king and queen focus just on having more eggs and everybody else does the rest of the work. And that term physogastry that you'll see there, it's a fun word. I like it. I like saying it. Physogastry is essentially where the queen goes from this skinny, svelte, roach-looking little creature to this giant egg factory. Her abdomen can swell up absolutely massive. These are actually very small examples of how big their abdomens can get, especially in African and Australian species. Their abdomens can get gigantic, like inches long, which is kind of insane to think about. Excuse me. So let's talk about some of the basic behaviors we see then. So just like the word alloparental, allo grooming. Essentially, termites live underground. Underground, there is a lot of dirt, there's a lot of fungus, there's a lot of little particulates that can get everywhere, and it's really important for them to stay clean. So essentially, even though the workers and soldiers don't have eyes, as soon as they kind of touch and rub up against one another, they will frequently move their mouth parts along each other to make sure that they're clean. It prevents disease and fungus and other issues from building up in the colony. It's an extremely important behavior, not the most exciting one, but super crucial to colony health. Brood care. This is kind of an extension of allo grooming. Essentially, workers in the central nest where the eggs are will be moving around, cleaning the eggs, moving the eggs around, keeping them safe, and essentially making sure that all things go well. They're the nurses making sure that those babies are safe. Nest maintenance. This is the kind of stuff you guys are getting more used to seeing. These carton nests. All of this is being built by those workers. This is a mixture of termite poop, partially digested wood and cellulose fibers, ambient moisture and soil. It is kind of just, it is the clay, it is everything that comes out of termites. And fun fact, that carton material, actually, a colleague of mine from Japan at one point wanted to see if it could be turned into pottery, and the answer is kind of yes, depending on the type of termites and what they've been eating. So this nest material is extremely durable. I've gotten to hold examples of it that feel about as hard as like plaster, essentially. So, yes, well hydrated ones are a little bit squishier, but man, some of these really old versions can get very, very, very dense and very, very hard. So this is one of the questions I like to ask of the group again. Is anybody here on this chat a veteran? Doesn't have to be active combat, just anybody in the chat a veteran. Because this is when I like to give one of my silly examples as to why people are always asking me, oh, are termites, do they fight a lot? Soldiers, they got these big mouth parts, are they scary? And I love to address some veterans in the room. First of all, thank you for your service. Second of all, this is a funny little bit that I like to talk about. So essentially, the way that I describe this to people who ask, are termites aggressive? Are termite soldiers aggressive? What I always say is, so if imagine you're a human. Let me put you in the shoes, in the termite shoes. So you are in a complete complex. You're in an underground complex. You are blindfolded. You have earplugs in, and the only weapon you have is a knife that you can wield with your mouth. Would you want to fight? Would you want to attack other termites? Or would you slowly tippy tap your way through that place and stay as far to your side as possible in the hopes that you don't have to fight someone? Because personally, even on my bravest day, I am not about to use my mouth knife with no eyes to fight. More often than not, these soldiers are intending to defend. If they happen to come across other termites or other bugs, yes, they will fight back, but only so much to defend themselves to make sure that there isn't immediate loss of life. More often than not, they will just wall up any openings that allow other bugs into their space. Though they will rear back and try to kind of posture to be scary. More often than not, fighting is the last thing they want to do. Another behavior that is somewhat important, it is important to note here, is corpse disposal and cannibalism in termites. Obviously, colonies can get up to millions of individuals, which is crazy. Not all of those millions of individuals are going to stay alive the whole time. So, one of the things that's important to note is if a termite is injured and there is no other immediate signs of risk to the colony, as soon as their hemolymph, their blood, uh, is exposed to the air, they basically get eaten straight away. And otherwise, they will, if there's enough dead built up, they will bury them and close off that area. But all in all, their nutrient recycling is the priority here. Another key behavior that you guys are all familiar with is foraging. So in this case, if we're looking at foraging underground, it's important to note different species forage differently. I hope you guys can see this picture okay. On the left is Coptotermes gestroi, so that is the invasives, termites that are specific at this point to South Florida in the United States. And on the right, that's Coptotermes formosanus, so the Formosan subs. You'll notice that the Formosan subs have this massive branching network, whereas gestroi have these very few, very thin, very light on the ground tunnels. So it's important to think about what does foraging look like for the species you're fighting, because that can actually make a difference to how aggressive they are. And obviously, you guys all know Formosans are extremely aggressive in their feeding tactics. Also, mud tubes, the most reliable way to tell you've got termites other than those wings. Mud tube, I like the word, honestly. It is basically the same material you'll find in carton nests. Sometimes it is a little bit chunkier because they're really trying to keep themselves safe. It keeps them in a space with high humidity, and it also keeps them safe, not just from desiccation, so from drying out, but also from all the things that would eat them because they're a great source of little microprotein. Birds, reptiles, all sorts of things will eat them without question. Also, the differences in how they feed extend to how they feed their way through wood. So there's kind of two main ways termites feed through wood. Subterraneans will feed along the grain. So you'll see that top left where it's kind of, you can still see the outline of the wood grain versus on the bottom right there, they're cutting across the grain. So dry wood termites, for those of you who may not have experienced them as much, they nest in one single piece of wood typically. They're not going to be foraging out as much. So they eat their way through all of the wood material, whereas subterranean termites will typically limit themselves to just the softer parts of the wood, as opposed to the lignin-rich parts in between those layers. Excuse me. Another really important behavior is trophallaxis. So, like I mentioned to you before, termites have gut symbionts. So, essentially, the way I describe it is it's kind of like if any of you have ever had a friend or someone you know that likes kombucha or Greek yogurt, that they're really into their gut microbiome and their probiotics. Like, this is basically the super intense version of that, but for termites. Because without their symbionts, termites themselves, biologically, can only digest a teeny tiny amount of the wood that they eat. It is their gut symbionts that are actually able to break down wood and cellulose into something that they can turn into energy. So, obviously, it's super crucial that they have those symbionts, but how do they get them? So, when a termite is born, or when a termite is has just molted, they have no gut symbionts, 0%. So they have to get them from other members of their colony. How I said that we know that there's biparental care, it's because that king and queen pass those symbionts off to the other members of the colony. There's two kinds, stomodial, which is essentially termite mouth to mouth. So they can either share symbionts, they can also share food this way. It's very easy. Honestly, sometimes they don't even fully eat the cellulose particles. They'll just hold them in their mouths and pass them along to the next one. But this is the pretty well-known, straightforward version. Then there's the nasty version. This is the, I got clear to say this, this is the human centipede version of trophallaxis. This is from the back end of one termite to the mouth of the other. It's a really good way to get that symbiont load moved from one to the next. And this prophylaxis will come up shortly again because it is an extremely important behavior. So, control today. This is the crux of this. And oh heck yeah, I'm right on time here. So essentially, control today. There are different methods for different types of termites, right? You have the control methods for subs, control methods for drywoods, and the things that are kind of an overlap for both. For subs, and I'm being very broad here, so cut me some slack. Generally speaking, you have liquid or bait. Those are the main two ways you're going to be getting at subterranean termites. For drywoods, it's a little harder, a little more complicated. You're seeing spot treatments, heat, fumigation. For both of them, wood treatments prior to construction. So that's heat treatments, chemical treatments, all those different ways of protecting the wood structure of a home. Physical barriers, that's things like underneath the foundation, encapsulation of crawl spaces, all that good stuff. And I put inspection on here with a little asterisk. Technically speaking, inspection isn't a control method, but as you all know, that's the starting point. That's the baseline for establishing what of the rest of these things need to happen. Now, I'm going to focus today on talking about the why and the how, why it works and how it works of liquid control and bait control for subterranean termites. Because again, I want to empower you guys to understand why these things actually work, how they actually work, so that you can be more empowered in the next time you go out and do a control. So for liquid termiticide, aka quote unquote non-repellent liquid termiticide, and I do put air quotes on non-repellent. Now, I'll explain what that means. I'm not coming for liquid termiticide. I don't have any beef with them. I'll explain to you what I mean. So when you go out to do a liquid treatment, you measure your perimeter, you dig your trench, you treat that trench, and in theory, the house is completely protected, at least around that base, right? So, termite comes to that edge of that barrier, and it dies because it is not repelled by that liquid termiticide, but it is killed by that liquid termiticide. And yep, that does work. That is correct. However, the next time a termite shows up, yeah, they'll also get killed, but eventually what ends up happening is there ends up being a buildup of dead termites around parts of the edge of that trenched and treated area, which ends up turning into something where the next time a termite shows up, it's out of there. Because while the actual termiticide itself is not repellent, as with, I think, most animals, a buildup of dead siblings is definitely enough to repel you from the area. So, termiticide itself is not repellent, but the dead bodies are. And it's important to note, liquid termiticide almost never results in colony elimination. And as you can see here, it is extremely crucial that it is applied correctly. It still absolutely does what it says on the tin. It does create that barrier when applied correctly. So it's super useful as a means of control. Just keep in mind the utility here, not eliminating colony. And as with most control methods, termites still can fly if they're dispersing. So it's still important to do inspections regularly because protecting the ground level is great, but they can absolutely get over the ground level. Now for bait, there are three things that bait exploit. Because one of the things here we're looking at is colony elimination, right? So it is exploiting three main behaviors: that cellulose feeding, like we talked about, repeated molting, hemimetabolism, and trophallaxis. So how does it do that? The main compounds in termite baits are CSIs. And I'm not talking about the fun crime show. I'm talking about chitin synthesis inhibitors. What does that mean? Well, for those of you who don't know, which I'm assuming most of you do, chitin is a protein that makes up that strong exoskeleton in most, if not all, insects. It is all insects, I believe. And in order for them to molt correctly, they have to have correct chitin synthesis that has to be reproduced correctly in their bodies. The way that I kind of would describe it is our skin cells fall off regularly and new skin is growing underneath all the time. A chitin synthesis inhibitor essentially would be the equivalent of your underlying skin not growing back correctly. So as those outer layers slough off over time, you don't have new skin underneath. So in termites, what that essentially looks like is death during molting. So how does bait kill one termite? Well, to start, a termite has to eat the bait. Pretty straightforward, pretty obvious. Next, later in its life cycle, like I said, every 45 to 90 days, the termite will return to the central nest area to molt. We've confirmed this. This is actually part of one of the studies that I did during my degree. We know that termites don't just molt anywhere. They return to that central nest, typically where the king and queen are, not always, but typically, to molt. So they're not at the site of the food. And then because they've eaten that bait, the synthesis of chitin is inhibited and they can't molt properly and they die. Makes sense. Very straightforward. That is how one termite dies. But how does bait eliminate an entire colony? And if for those of you who've been paying attention, I've given you some of the tips on this, and I think that you'll get there before me. But hopefully, for those of you who aren't getting it, let me show you. So for a purple termite here, a termite it's eating the bait, and it's important to note in the time frame between eating the bait and going back to the central nest area, it is able to pass that bait around the entire colony via trophallaxis. Now, trophallaxis isn't a super common behavior, but it is still a crucial behavior. So they're not allogrooming. Termites do that several times, typically within a couple minutes. And this is from my own personal experience observing them. They're allogrooming all the time. Trophallaxis is a little less common, but it's still, I mean, let's say 1 to 2 instances of trophallaxis in a 10-minute period. And 10 minutes across 45 days or 90 days, depending on how early they get exposed to bait, that is a lot of time passing bait around. And it's important to note here, the beauty of a chitin synthesis inhibitor is it doesn't matter how much they're exposed to. Whether a termite eats the bait or is exposed to bait through trophallaxis, it is exactly the same biologically. They are still in trouble. If they've been exposed, they've been exposed. That's it. They're in trouble. So our purple termite has passed that bait around the colony via trophallaxis to our red termite, our new red termite. And every worker that they've exposed to that bait via trophallaxis will die during their next molt. So it becomes a pyramid scheme. So if we follow now the red termite that has been exposed via trophallaxis, it does the same thing to the blue termite. And all of the termites that they then pass that bait off to via trophallaxis are now going to die during their next molt. And on and on and on until all of the colony is exposed and dies during their molt. So a couple of things here. How does this cause the colony to collapse? Well, as I said, soldiers and reproductives rely on workers for food. A dead termite cannot provide food. Spoiler alert, if a termite's dead, it's not providing any new cellulose material to the colony. Those dead termites build up in the central nest. Like I said, they die during their molt, and they will only molt in the central nest. So reproductives typically will have to waste energy moving to a new central nest location as that buildup of termites, of dead termite corpses, gets worse and worse. And as I mentioned with corpse disposal, the workers will sometimes eat dead termites, which will also expose them to that chitin synthesis inhibitor in this case. Although, as I said before, at a certain point, the volume of corpses will become too big, and they are at that point smart enough. Once those decomposition pheromones reach a certain limit, they are instinctively aware enough to know, oh, I shouldn't eat this anymore. But still, it's enough to keep pushing it through the colony. In addition, as that population begins to drop off, those reproductives have to lay more eggs, which is super energetically costly, especially if they're not getting fed enough. And if they are exposed to chitin synthesis inhibitors, those reproductives don't continue to molt in the same way, so that won't kill them in that same method. However, that the CSI will be passed off and can cause problems with the eggs that they're laying. In addition, any larvae, any of those offspring, are getting exposed to more and more CSI earlier, the younger a termite is, the faster it goes through molts, which means it's going to kill that colony faster and faster. So essentially, you get to a point of breakdown here where soldiers aren't getting fed, the reproductives aren't getting fed, and now you have colony collapse. AKA, there's nothing left to be done, it is on its way out. And in order for colonies to collapse from bait, they really only need two main things. 2.5 to 5% of the foraging population needs to be exposed to the bait directly, which I want you to think about that number for a second, because that is an exceptionally small proportion of a colony. When you're thinking about Formosans, their colonies can get to millions and millions of individuals. That is such a small amount, especially considering as they find a food source, a really reliable one, like, I don't know, an undisturbed bait cartridge, perhaps, they will move into that space very quickly and very readily and continue to be exposed over and over. Now, this number actually is pulled from a really, really good study. For those of you who are curious, I do have citations on some of these pages. This paper is really great, talking about how basically it is such a small percentage that needs to be exposed. It needs to be more than 2.5%, but they had full colony elimination with less than 5, so it's somewhere in there. But really, if you think about it, crazy how small an amount that is. And approximately 3 months from that first exposure to bait. Like I said, most termites molt within 45 to 90 days, give or take. Now, that molting is asynchronous, aka that it's not at the same time. So termites are molting continuously. I want to say about 1 to 10% of a colony is molting at any one time. Something in there. I need to check my numbers on that, but a small proportion of the colony is in the middle of molting at any one time. So that 3 months essentially guarantees that you've had enough individuals exposed for that colony to completely collapse. Excuse me. That is kind of the shortest time frame where you know that they've been exposed. That is also from a really good paper. Most of these are coming out of the Chevank and Sue work from that lab at the University of Florida. Now, a question I get all the time is, why do we space bait the way that we do? Why do we space bait the way that we do? Why does it matter? What does the label say? How do we know? And a really good friend of mine, who was at the Sue lab the same time as I was, actually did her master's on exactly this question. So the title of her paper, which I'm not going to force you to read, but I'm going to encourage you to read because it is really, really well done, is Subterranean Termites Colonies can readily intercept commercial in-ground bait stations placed at label prescribed distance. What does that mean? What is she trying to communicate to us? What is that telling us? Well, here are two extremely important quotes from this paper that get across her point. So to quote the paper directly, our results showed that colonies took an average of 21 days to find at least one of the bait stations placed at the uniform interval of 3 meters as instructed by most commercial bait products. Basically, I've bolded, highlighted, and underlined that important point for you. 21 days to find the bait station. So how I said a couple slides back, colony needs 3 months from exposure to bait. That means that you are expecting about 4 months, give or take, assuming you've got aggressive termite activity in the area, about 4 months to have colony elimination, accounting for those 21 days. In addition, because I've had people ask, why don't we just kind of start throwing as much bait in the ground as possible? I'll cut to the chase here on this one. Termites intercepted bait stations significantly faster only when they were 0.45 meters apart. Thus, baiting programs need to install 4 times more bait stations to achieve this efficiency. This approach may not align with the principles of integrated pest management. So what does that mean to you guys tangibly? Because when scientists say significant and when normal people say significant, they mean something slightly different. In this case, essentially, what Ms. Gazdick was saying is essentially you need a massive amount more of termite bait in the ground in order to see that time frame decrease in a way that is measurably better, which obviously is, as most of you would know, financially and labor wise, a really unreasonable thing to do in order to get a slightly faster time to hit. So just keep that in mind. If customers ask you why you do it a certain way, we know that it works. We know that this is the most effective way, and it makes no sense. So as always, follow the label. The label is right. And as we come kind of toward the end here, I want to leave a little bit of room for questions at the end. I will leave you guys with IPM. I always rehash this. I know that most of you have to do your CEUs, continued education work, all the time, but I always talk about IPM at the end here. Obviously, we want to provide effective service, kill pests, and protect property, but we also want to do right by our customers, nature, and protect yourself as a pest control operator. Because, you know, while chitin synthesis inhibitors in bait are pretty much harmless to humans, because spoiler alert, we don't have chitin, it's important to note that anytime you're out doing any sort of treatment, regardless of what you're using, keeping yourself, the environment, and your customers safe is obviously the biggest priority. Because yes, we want to get rid of insect pests, but we have to be here and healthy to benefit from an absence of pests. So this is from the EPA. This is a bit of an old quote, but I really appreciate it and kind of always want to hammer it home. I don't know if this is still up on the website, but it was when I found this. So IPM programs use current comprehensive information on the life cycles of pests, which you guys now have gotten more info on, and their interaction with the environment. This information, in combination with available pest control methods, is used to manage pest damage by the most economical means and with the least possible hazard to people, property, and the environment. All that is to say, you guys are out there doing an amazing job. Most of these termites that I touched on today are invasive. They are not meant to be here. Formosan subterranean termites are not meant to be in the US, and they cause huge problems. Now, eastern subs are a native species, but it is still important that they cause massive economic damage, as you all know. So it's important, obviously, here, any invasive species means it was a mistake on the part of humans in the first place. It's up to us to try and rectify those as best as we can without causing additional problems. Thank you guys so much for listening, and I will now happily take questions, comments. I'm pretty interested to hear if you guys have anything to say back.
So I thoroughly enjoyed that. I love any talk about termites in general. But Angel had a question. He said Termidor touts that it's a non-repellent, but doesn't kill immediately, so they die somewhere else. Why is this not an effective way to eliminate termites?
So, to my understanding, for Termidor, and again, I'm not super well versed. I only got a lot of my background on the actual control methods as I've worked in the industry, which I think I just had my 2-year anniversary last month. So I can speak more to the biology certainly than to the control methods. But what I've understood with Termidor as compared to something like a bait is it doesn't pass through the colony as effectively. So it's still going to kill termites that are exposed to it, but it's not going to move through the colony at speed. It's not going to have that colony elimination efficacy per se, just because it, like, great, yes, it will, termites that are exposed to it, yes, they're going to die. And it is better that they're not going to die right at that line. But yeah, it's not going to pass through a colony in quite the same way. I hope that answers your question.
And I saw a study out of out of your home university that showed the possibility of secondary repellency.
Yep.
So you get far enough away, they do realize that something's killing them. I think
Yep.
Thermidor is a fantastic product.
Oh yeah, by the way, I want to make really clear here, I am not saying liquid is bad. I'm not saying bait is better. All I'm saying is that there is a solution for every problem, but not every solution is for every problem. So definitely keep in mind it is also my default that I say is always whatever your company, whatever the label is, whatever the assigned schema or plan is, do that. I am just trying to
Exactly.
educate you and provide some information on some background. This is not my way of saying do one or the other. I don't care. They both do what they say on the tin. Just putting that out there.
So Jason said, "Thank you for your great time and information." And then Paige said, "How likely is it for another colony to move in where the previous colony was, with the old colony being exposed to the bait?"
Very, it is very likely. So there is another, several studies actually out of New Orleans. Um, the SULAB and was it the Pest Control Board of New Orleans? They're first of all wonderful collaborators of ours. I absolutely love them to death. And there is a it was a control operation done called Operation Full Stop in the French Quarter of New Orleans. This was done in the early 2000s to 2000 teens, and there was several pieces of work coming out showing exactly that colonies ebb and flow and move into each other's spaces, and they will absolutely take advantage of the pre-dug tunnels and the carton that has already been built by other termites. So the answer is, how likely is it for them to move in? Extremely likely, which is why it's extremely important to keep up with maintaining that bait, maintaining any sort of barriers that you've put out, whether it's liquid or bait, because you are always, running the risk of other colonies moving in, especially in areas where there's very high termite pressure. For all the Gulf coasters, definitely keep that in mind. That's a really good
So
question, though.
that, yep, that was a really good question and a great answer too, because the infrastructure's there. How much easier is it for them to exploit that as well as the resources they had stockpiled, which might include bait had you used bait for control.
Exactly, precisely.
So